are live. What's up, guys? This is Dem Keys, and holy shit, dude! It's man, the days kind of got away from me. It's been what 12 days, I think, since I last streamed. Actually, no. Hold on, not 12. Okay. I'm happy about this. It hasn't been 12 days because I was looking at the date shortly before I started the stream. I was looking at the date, and we are currently in the 12th month. So I kind of got confused looking at 12 because the Windows um, time display thing, it shows it shows like month, day, and year. So, okay, anyways, I'm going into unnecessary detail with this. So, I last streamed on the 30th of last month. So, it's been about a week. And that's not great either, but considering that I was thinking that it's been 12 days, I'm happy that it's only been a week. I'm still not happy about the fact that I didn't stream for a week, but the days kind of like got away from me and I just wasn't able to uh, get the right time to stream. Though, to be fair, I could have been doing mute streams during this time. I don't know why I didn't think about doing that because I mean, I want to keep like a regular streaming schedule. By the way, somebody on one of my and I was happy about this because someone was actually curious about this. So like I upload the VODs for these streams that I do. I upload them to a separate YouTube channel that I've made for specifically for the VODs. That's separate from my main channel and my second channel. This is like the, I guess you can call it the third channel, which is mainly just for it's mainly just a VODs channel. It's I'm not doing anything else there. And somebody commented on one of the videos asking what my stream schedule was. That was kind of a new experience for me because I haven't had that happen before. But yeah. Um, so I kind of want to try and have a schedule. Um, I don't know. I mean, I'll try. You know what the thing is? I'm still kind of like torn between wanting to only do talking streams and wanting to do a mix of mute and talking streams. I don't want to do. By the way, hold on. I just noticed I still have the hashtag neural net November thing. It was a silly joke that I'd come up with for November. But yeah, okay. Shit. I forgot what I was saying. Um oh yeah, so it's I'm kind of conflicted between wanting to always do talking streams versus wanting to do like a mix of mute and talking streams, because if I do a mix of mute and talking streams, I will actually be able to maintain a schedule. um I'll be able to maintain a fixed schedule and stream at a specific time. And actually, you know what? No, if I incorporate mute streams, I'll be able to stream at other times as well. The reason I'm not able to do talking streams is because I'm mainly only able to do talking streams during a specific period of during a specific period of the day time during a specific time of the day. um and once that time frame is passed, I won't get a chance. And then I have like other than that, I have like the rare occasions like today where I get a chance to do do a stream during a different time of the day. I think I might get another chance tomorrow. I'm gonna have to see. I'm not sure, but I think I might get a chance tomorrow as well to stream at this time, which is great. I'll try my best to stream. But yeah, dude, I think I should. I don't know. I'm still kind of conflicted because I want to do mute streams. No, I want to stream. I want to maintain like a streaming schedule, but like the talking streams aren't necessarily always possible. So on days where the talking streams are not possible, I would like to do mute streams, but then um sorry, got distracted. On the days where it's not possible, I would like to do mute streams, but then I much rather I very much prefer um doing talking streams, which is why I wanted to try and set up a text to speech system where I can type in the messages that I want to be, spoken or said, messages that like when I want to talk. um I could, during my mute streams, I could set up something like that. um yeah, okay, so um it's good to be streaming again. And for today's stream, I wanted to try. Give me a second. Let me open this thing up. For today's stream, I wanted to try and go through this course. This is a course called a Small Course or a Smol Course by HuggingFace, and I found this interesting. So the course is still it's like currently taking place. It's like actively being built. The entire course is not done yet, which is great because I'm catching the thing early on. Um, I'll read out the entire thing. I just want to show you the course outline. So there's a couple of other things that aren't done yet, and they're planned for later on, which is great because like I'm pretty sure each of these modules I'm gonna I'm gonna be taking some time with them. I don't know what the prerequisites are. Oh, you know what? I didn't look into this. Okay, so prerequisites. Before starting, ensure you have the following: basic understanding of machine learning and natural language processing, familiarity with PyTorch, Python, and the Transformers library, access to a pre-trained language model, and a labeled dataset. Okay, you know what? You know what? You know what? I think I have all of those. So, I mean, I have a basic understanding of machine learning. At least I like to think I do. There's still quite a bit that I have to learn about NLP. So I don't know if that's going to be detrimental, like me not having too much NLP knowledge. I'll get there. Hopefully, maybe throughout this course, I'll be introduced to terms that I can then research, and I'll learn more about NLP that way. Because anyways, I was planning on researching NLP related stuff, right? Because there's a fair bit of a lot of the stuff that I plan on doing, to a certain extent, it does involve prompting in some way or NLP in some way. So I'm gonna have to learn like a bunch of these things, and I kind of want to learn it anyway. So it's not like it's not like a burden that I have to learn it. I do want to learn it anyways. So it's just about when I get to it. Because I did plan on eventually getting into learning about building LLMs. Speaking of which, that 5-day Kaggle course, I need to at some point get to that as well. I don't want to wait too long, in case that knowledge becomes a bit outdated. It's fresh right now, fresh as in, I don't know. I think it's been a month. I think it's been a month. I'm not sure. Um, but yeah, it's still fresh. So I kind of want to go through it while I have the chance now, because there's a fair bit of stuff in that course that I don't know about. Like, to give you an idea, I didn't even know that Google AI Studio was a thing. until I watched like the day one of that course. And even the day one thing, it's not just one video. There's a bunch of other videos like for day one, and a bunch of like they have separate videos. There's this interesting thing they've done where they've set it up in like a podcast format, but the two podcasters are AI voices. And somebody has set up a script and the AI voices are reading it out. So it kind of sounds like a conversation when you listen to the video, when you watch the video. It kind of sounds like two people are having a conversation. And as you're listening to that conversation, you get to learn more and more about, well, the topics that they're discussing, because they've set it up in such a way that um, they'll start discussing a topic, and then one person will ask, hey, okay, what does this do, how does this work, and then the other person will respond, and then maybe one person will have a doubt that, hey, what if XYZ, and then the other person will respond to that as well. So it's interesting. I like the way that they've set that up. It's pretty great. I think this was the first time that I was seeing. I mean, I knew that these kinds of things existed, and the tools for these, more specifically, I knew that the tools for these kinds of things existed, but I hadn't actually taken the time to listen to somebody's um, AI made podcast. I'm not sure what terminology to use there. But yeah, this was the first time that I was listening to that kind of thing, and dude, I kind of like it. I'm, dude, I like it. I like that idea. But yeah, I do wanna I do wanna go through that 5 day course thing as well. That's by Kaggle, and this course is by HuggingFace. This is called a Smol Course, and this is sort of an open course from what they mentioned. It was mentioned somewhere here. Um, Yeah. This course is open and peer reviewed. To get involved with the course, open a pull request and submit your work for review. So I'm guessing this course is being developed by the community, and anytime you have something to add, you can add it um, through a oh yeah, you can add it through a pull request, or if you find any bugs or any mistakes or anything, or anything like that, you can create an issue and they'll fix it. So this course is essentially being built up by the community, which is amazing. Okay, you know what? Let's get started. Give me a second. Let me hydrate, and then we can get started with this. Hopefully, throughout this course, I'll get to learn more about LLMs, and more specifically, I think this course, it says a course on aligning small models. So I'm guessing this course is for fine-tuning small models on very specific tasks, which and more importantly, fine-tuning small models that are capable of running locally. That's an important that's an important bit of information. This course is for, at least that's what I think it is. Um, at least that's what I think it is. I think it's about fine tuning. So, sorry, I'm watching someone else's stream and I'm getting distracted. Okay, yeah. I believe this is about teaching you how to not just fine tune, because like fine tuning is one small part of the. I think fine tuning is one small part of the equation. When they say aligning small models, I think it's like a combination of a bunch of things, and fine tuning is just one of those things. There's a bunch of other things that you would have to do to set up the model to behave a certain way and um, accomplish certain goals, accomplish certain tasks. I forgot where I was going with this, so I'm just gonna. Okay, yeah, I was supposed to hydrate, and then we need to start reading this. We're gonna be reading day one, module one. I think it's module one. Apparently there's seven modules, At some point, I'm probably going to have to go look for a model as well, a model and a data set, which shouldn't be a problem because there's tons of them on Hugging Face, tons of like open ones, open source ones, which shout out to, all the people that are doing that work for us. What was I saying? Yeah, at some point I might have to go and look for models, or hopefully in the course they might give some suggestions for which models and data sets we could be using. I plan on using Kaggle, my Kaggle notebook, to do all of this stuff because there's no way I'm gonna run this on my own machine. The performance on my machine is just horrible. It's not gonna be a good time for me. So doing it through Kaggle is a much better bet. So give me a second. Let me hydrate, and then we can start reading. Uh, okay, all right. So a small course. This is a practical course on aligning language models for your specific use case. It's a handy way to get started with aligning language models because everything everything runs on most local machines. There are minimal GPU requirements and no paid services. Hell yeah. Uh, the course is based on the small ML, no, the small LM, the small LM2 series of models, but you can transfer the skills you learn here to larger models or other language mod or other small models. Okay, so there is a link here. So everything about small LM and small LM2 family of models. Okay, all right. So, a small LM2 is a family of compact language models available in three sizes: 135M, 360M, and 1.7B parameters. They are capable of solving a wide range of tasks while being lightweight enough to run on device. You can find our most capable model here. All right, so that is a link to the model. And this is the link that I had clicked earlier. They probably have like a bunch of the models here. This is Hugging Face TB research. Oh, this is interesting. Okay, I'm guessing these are the data sets, and then this is the, or well, this I guess this is the group, and then these are the specific models. And I'm not sure what this is. This is okay. This says instruction tuning. Okay, all right. This says pre. Okay, I'm now slowly noticing all this small text that I didn't see before. So okay, yeah, these are the data sets. Some information was scraped from the web. Some was taken from textbooks and other sources. And then these models were trained on that text, on that information. So then you have the models. What does this say? Language backbone? Okay, so I don't know enough about. So I've heard the term backbone before, but I haven't like fully gotten an understanding of it. I think one of the reasons I haven't gotten a proper understanding is because I haven't had to use it myself yet. Because I'm still learning how to build neural networks, which which reminds me I need to get back to doing the fucking feed forward neural network stuff so that I can then progress to convolutional neural networks and recurrent neural networks, and then even more complex architectures. But I want to finish those three first. I keep getting stuck on that, and I'm taking way too long with it. Okay, so backbone, and then instruction tuning. So I know nothing about exactly what instruction tuning is. You know what? Give me a second. Let's. I just remembered that I'm supposed to open up. I'm supposed to have an instance of Llama open. What was it? Labs.perplexity.ai. Okay. Um, I'm learning about, what should I say? I'm learning about deep learning. What is a backbone? I wonder if I should give it some more context so it can give like a better answer. Oh, you know what? Okay. I'm learning deep learning with PyTorch and HF transformers. So hopefully it's going to give some information around these two libraries. What is a backbone? In the context of deep learning, particularly in computer vision and related tasks, the term backbone refers to the primary component of a network, of a neural network, that is responsible for feature extraction from the input data. Feature extraction. The backbone is essentially the feature extracting part of the network. Okay, so I feel like to understand this, I would need to I would need to understand what different parts of a neural network do and how you can set up different parts of a neural network to do different things. So I would have to set up a scenario where I need to do feature extraction in order to actually understand like what's going on here. Okay, it processes the input data and generates a feature representation that can be used for higher level tasks such as object detection, image classification, and segmentation. Architecture. The backbone typically consists of a series of layers, including convolutional layers, pooling layers, and sometimes normalization layers. Okay, so this is a convolutional neural network. These layers work together to downsample the input and capture important patterns and representations in the data. Examples of backbones. Common architectures used as backbones include ResNet, Exception, MobileNet, ConvNet, and various transformer based models like Swim Transformer and Vision Transformer. Okay. Modularity. The backbone can often be swapped out or modified to suit different tasks or to leverage pre-trained models. For instance, in the DeepLab version 3 architecture, the backbone could be ResNet 101 or Exception, and these can be interchanged based on the specific requirements of the task. Yeah, I've seen a similar thing in PyTorch as well. PyTorch does give you the option to like switch out the backbone. I've seen something about changing the backbone using different backbones. PyTorch itself does also provide you with backbone architectures. I don't know about the data for those networks, like or the weights for those networks, but they provide you with the. I'm pretty sure they have something set up for weights as well. They probably have like some test weights or some open source weights or something that you can download. But yeah, PyTorch does give you that option because I remember reading about backbones. I'd first started researching backbones when I'd read it during when I was studying PyTorch. Okay, integration with other components. The backbone is often combined with additional components such as feature pyramid networks or other task-specific heads to complete the full model architecture. You know what? Okay, I have an interesting question here. I only know about FCNNs. You mentioned the word head. What does that mean? Actually, I wonder if backbones are mainly convolutional neural networks. Okay, in the context of deep learning, particularly when discussing neural network architectures, the term backbone and head are used to describe distinct components of the network. The backbone is a primary feature. Okay, we got that already. The head is the part of the network that takes the feature representations generated by the backbone and performs a specific task or tasks required by the application. Here are some key points about the head. Okay, you know what? We can go into this later on once I've gone deeper into different neural network architectures. Give me a second. Okay, so uh, where were we? So we are looking at small LM2, and in here, I'm gonna need to find. I think I can go for the smallest one, so the inference is faster and the training is faster as well. Usage. Okay, our most powerful model is so and so, which you can use as an assistant with transformers, TRL, or using quantized versions with tools like Llama CPP, MLX, and Transformers.js. For lighter applications, you can also use the smaller models, which are suitable for on-device usage and can be integrated similarly. All available in this collection. Okay. All right, so this is what I'm looking for. Okay. Um, I'm gonna go for the smallest one first, so that just so that fine tuning and any other training related things are quicker, and also so that inference is quicker. All right. So I'm not sure what TRL is. Give me a second. Oh, you know what? Let's. I'm learning about HF transformers. What is TRL? Chat in TRL. You can also use the TRL CLI to chat with the model from the terminal. Let me try asking the question in a different way because I wonder if this is like a different thing. What is the TRL CLI? What is? Hold on. What? Wait. Let's go back here. Let's see what this says. So, TRL or Transformer Reinforcement Learning is a library developed by Hugging Face that focuses on post-training foundation models, particularly large language models using reinforcement learning and other advanced techniques. Sorry, zoned out. Okay, reinforcement learning. TRL utilizes methods like proximal policy. Oh wait, I missed the ad timer. So there's going to be an ad starting in a bit. Uh, I guess I'll take a hydration break when that. Actually, no, I need to also take a short bathroom break. So, uh, you know what? I'll just switch to BRB, and I'll be back in like a couple of minutes. By then, the ad should also be over. All right, I'm back. Um, I don't know. I think it's been a couple of minutes. I think I took longer than I expected to. Okay, so let's carry on with this. Okay, so TRL is it's a reinforcement library. It's a transformer reinforcement library by HuggingFace. TRL is primarily used to fine-tune generative models to follow instructions or generate text with specific properties, such as movie reviews. It is particularly useful in reinforcement learning from human feedback scenarios. Training techniques. Okay, all right, real quick. So I'm not familiar with TRL. I'm familiar with the Transformer library or the Transformers library. So let's see. You can also use the TRL CLI to chat with the model from the terminal. Oh, okay. You can use it to chat with the model. All right, that's okay. Um, you can find more details on how to leverage the model for use cases such as text summarization, text rewriting, and function calling in the model card. Okay. So, local inference. You can use the models locally with frameworks like Llama CPP, so and so, so and so, so and so. You can find the instructions to run small LM2 with these frameworks at local inference. Small tools, a collection of lightweight AI powered tools built with Llama CPP and small language models. These tools are generated, no, these tools are designed to run locally on your machine without requiring expensive GPU resources. Okay, pre-tuning. You can find scripts for launching pre-training, not tuning. You can find scripts for launching pre-training with Nanotron under pre-training. We share the exact configs for training small LM1 and we'll upload small LM2's configs soon. Okay, so why did I come here? This course is based on the small LM2 series of models. All right, cool. So we're gonna keep the repo aside for a second. Let's only look at the models. So I'm currently interested in these two, 135M and 135M instruct. Uh, so we're gonna focus on that. Participation is open and free, is open, free, and now. This course is open and peer reviewed. Give me a second. Okay. Oh, actually, just a minute. Just a second. I'm just doing something here that needs to be done. Okay. All right. Great. Awesome. Where was I? Yeah. So this course is open and peer reviewed. To get involved with the course, open a pull request and submit your work for review. Here are the steps. Fork the repo, read the material, make changes, do the exercises, add your own examples, open a PR on the so and so branch, get it reviewed and merged. This should help you learn and to build a community driven course that is always improving. I really like that idea, dude. A community driven course. I mean, I'm sure this isn't like this isn't the first time it's being done, but I do want to see more, a lot more AI related community driven courses. Um, Whatever it may be, data science related or machine learning related or Gen AI related or whatever. I would definitely like to see a course that's constantly improving. Sorry. Okay. So okay. All right. Oh, just a second. All right. Course outline. This course provides a practical, hands-on approach to working with small language models, from initial training through to production deployment. All right, cool. So we are going to be looking at this. Actually, I don't think I opened it up. Did I? Can you stop scrolling? There you go. Okay. Uh, we'll get to that in a bit. First, let's read the remainder of this. Okay, why small language models? While large language models have shown impressive capabilities, they often require significant computational resources and can be overkill for focused applications. True, yeah. You don't need you don't need an entire like llama model if you just want, let's say, a bot that can be instructed to do certain specific things. You don't necessarily need a fully conversational or a fully conversation capable model. Just something that can understand the instructions and maybe give you back basic basic responses. Where was I here? Yeah, okay. Small language models offer, you know what? Actually, quick thing. I think ever since I've gotten into AI, this is the first time I'm hearing about small language models. I've only ever heard about large language models. Yeah, I don't think I've ever heard about small language models. Prior to LLMs becoming a thing, I knew that there were models being built with specific conversational capabilities in mind. So they were being built for specific things. I don't think they were necessarily the same as small language models because small language models are more general purpose, just like at least my assumption here is that small language models, just like large language models, are more general purpose. So they're trained on like a very general set of data or a common set of information so that they'll have that very basic capability that I words, that very basic capability. But then you have to fine tune it to make it do specific things. I forgot where I was going with this, so I'm just going to carry on reading. Small language models offer. Oh, yeah, I just remembered. I was talking about how I don't think I've ever heard about, or I don't think I had ever heard about small language models until, or ever since getting into AI. I hadn't heard about small language models until now. I've only ever heard about large language models. And of course, prior to large language models being a thing, there were language models developed for specific purposes, specific requirements. Give me a second. Okay. All right. Small language models offer several advantages for domain-specific applications. Efficiency. They require significantly less computational resources to train and deploy. Customization. They're easier to fine-tune and adapt to specific domains. Control. Better understanding and control of model behavior. Costs. Lower operational costs for training and inference. Privacy. You can not you can they can be run locally without sending data to external APIs. That's a good point, actually. No, that's a very good point. Because even where I live, like we are starting to see more and more AI being adopted, more and more AI tech being adopted, and for example, you have like banks. Banks are starting to adopt specific language models as their help desk, I guess you can say, as their uh, I don't want to say tech support because like that's not necessarily like a bank thing, but like their help desk, their customer service representative. It's not really a customer service representative. It's a model. It's a bot that can handle the most general tasks, and it can probably answer like the most general questions. But then if it's something that's a persistent problem, or if it's something that requires human intervention, then that bot is gonna file a support ticket, and then an actual human is gonna give you a call and sort out whatever problem you're having. So we're starting to see these different institutions adopting this technology, and as we see more and more of them adopting this technology, they would definitely be worried about privacy, right? Because they don't necessarily want their data being sent over to another service, or their data being leaked in general. So if the models are running locally, then they don't need to worry about the data getting leaked, or the data going to a service, or the data going to a third party service that they don't want the data to go to. Okay, green technology advocates efficient usage of resources with reduced carbon footprint. Okay, easier academic research development, provides an easy starter for academic research with cutting edge LLMs with less logistical constraints. All right, so we've read the prerequisites already, and we already have. Okay, so we have access to transformers already, PyTorch as well, if required, and we already have a model. We're gonna have to look for a data set to fine tune the model on. I guess the course is gonna suggest something later on. All right. Installation. We maintain the course as a package so you can install dependencies easily via a package manager. Okay. We recommend UV for this purpose. What is UV? An extremely fast Python package and project manager written in Rust. That's interesting. Okay, cool, cool. I've never heard of UV, or I think maybe I've come across the name back when I was looking for like pip alternatives. I think I'm not sure. I don't remember. But hell yeah, dude. Great. You can also use pip. All the examples run in the same Python 3.11 environment. So you should create an environment and install dependencies like this. Or Google Colab. Okay. Engagement. Let's share this so that loads of people can learn to fine-tune LLMs without expensive hardware. Okay. What are the requirements? I think because I'm using the Kaggle notebook, right? So the requirements are probably already most of the requirements are probably already satisfied. If it's Hugging Face related stuff or Hugging Face transformers related stuff, I'm guessing that the requirements are satisfied. Then we have PyTorch related stuff. I'm guessing the NVIDIA CUDA and stuff like that is for PyTorch related stuff. Though to be fair, no, I don't think it would just be PyTorch because even inference is done on the GPU, or well, and even inference can be done on the GPU. Yeah, you know what? I don't think I need to install anything separate, but like if the need does arise, then Kaggle notebooks they allow you to install, you know, separate packages. So I think we're good. All right, so we can move on to the first module, which is instruction tuning. Okay, I'm first gonna need a definition on instruction tuning. I'm not seeing one here immediately, so what I'm gonna wait, actually wait, let's open up these two as well, because within instruction tuning, there's these two things, these two sections where there's additional information. Right, so let's get some basic information here. I'm learning HF transformers, or I'm learning about HF transformers and LLMs. What is instruction tuning? Wait, is that what the term was? Hold on. I don't I don't even remember what the term was. Yeah, instruction tuning. Okay. All right. Instruction tuning is a technique used to fine-tune large language models to improve their ability to follow instructions and perform specific tasks. Here are the key points about instruction tuning. Definition and purpose. Instruction tuning involves fine-tuning pre-trained LLMs on a labeled dataset consisting of instructional prompts, and their corresponding outputs. This method aims to enhance the model's performance in following instructions and performing tasks as requested by users. Dataset structure. Each training sample in the instruction dataset typically includes three elements: the input prompt, the instruction, and the desired output. These datasets can be manually created or generated by other LLMs. For example, the Alpaca dataset contains instruction following data generated by GPT-4 with prompts in the Alpaca format. Okay, fine-tuning process. Instruction tuning is a form of supervised fine-tuning where the model is trained to predict the output based on given instructions. The process involves adjusting the model's weights to make its outputs match the desirable responses in the instruction dataset. Tools like HuggingFace, tools like the HuggingFace ecosystem, particularly the TRL library and the SFT trainer. Oh, is SFT supervised fine tuning? I think so. Uh, are often used to facilitate this process by handling pre-processing data create pre-processing, dataset creation, and efficient parameter fine-tuning. Benefits. Instruction tuning improves the model's ability to follow instructions in general, reducing the need for extensive prompt engineering and few-shot exemplars. No, exemplars. I've heard this word before, but I don't know what it means. Give me a second. Let me look this up. Exemplars. Is that something that stands out? Just give me a second. Okay, an exemplar is a person or thing serving as a typical example or appropriate model. Oh, so then exemplary uh would be something that is considered an example, right? I always thought that exemplary, because I've heard the term exemplary more than exemplar. Um, I always thought that exemplary was more of like a, super positive, super like, I don't even know what to say. It's like a amazing. It's like another way of saying amazing. I always thought that that's what it was. Exemplary, like extraordinary. That's what I thought it was. But okay. Uh, wait. Could they mean different things? Hold on. What do exemplar and exemplary, exemplary, whatever. What do exemplar and exemplary mean? The term exemplar and exemplary are related but have distinct meanings and uses. Exemplary is an adjective that can have several meanings. Worthy of, oh shit, I accidentally hit my mic. Okay. Worthy of imitation. So this is what I was assuming, like exemplary or exemplar is it's kind of like, oh, you should learn from this. If you're ever going to learn from an example of something, or if you're ever going to learn about something through an example, then this is what you should use as an example. It describes something or someone that is extremely good and serves as a model or example for others to follow. For example, his exemplary conduct or an exemplary record of innovation. Um, the next meaning is serving as a warning. Okay. Okay. And then representative or typical. It can also mean serving as an illustration or specimen of something. For example, the sentences read read read. Okay. The sentences read are exemplary of the style of the essay as a whole. Okay. Exemplar. Exemplar is a noun that refers to model or ideal. Okay, so then the exemplar would be what is considered exemplary, right? Model or ideal example. It is something or someone that is fit to be. Yeah. Okay. So that's all right. Okay. Cool. Great. Why did I get like how did I get to exemplar? Was it here? Where was the word exemplar? It was hold on. Instruction tuning improves the model's ability to follow instructions in general, reducing the need for extensive prompt. Oh, there it is. For extensive prompt engineering and few-shot exemplars. It reduces the need for extensive prompt engineering and few-shot exemplars. Okay, it bridges the gap between the model's fundamental objective and fundamental objective of next word prediction and the user's goal of having the model perform specific tasks. This approach also enhances the model's performance on novel tasks not represented in the instruction dataset. Okay, combination with other techniques. What was I looking up here? I forgot. Uh, Instruction tuning. Okay, so that's what instruction tuning is. Cool. So we are gonna start reading. Actually, let's read this first, and then we'll move on to like each of the individual sections. Okay, instruction tuning. This module will guide you through instruction tuning language models. Instruction tuning involves adapting pre-trained models to specific. I just realized that the definition was right here. Fuck me, dude. Okay. Well, I mean, okay. So to be fair, I did get like a decent amount of information here. So I'm not even disappointed about that. Like, okay, cool. We got some more information. Great. Instruction tuning involves adapting pre-trained models to specific tasks by further training them on task-specific datasets. This process helps models improve their performance on targeted tasks. In this module, we will explore two topics: chat templates and supervised fine-tuning. Give me a second, let me hydrate, and then we'll carry on. All right. Chat templates. Chat templates structure interactions between users and AI models, ensuring ensuring consistent and contextually appropriate responses. They include components like system prompts and role-based messages. For more detailed information, refer to the chat templates section. Yep, we're going to be doing that. Wait, did I already open that up? Yeah, I think I did. Yeah, I did. All right, next we have supervised fine-tuning. Supervised fine-tuning, SFT, okay, is a critical process for adapting pre-trained language model. Wait, chat templates sets up templates that the user and the model are going to be sort of following. And then supervised fine-tuning is a critical process for adapting pre-trained language models to specific tasks. It involves training the model on a task-specific dataset with labeled examples. For a detailed guide on SFT, including key steps and best practices, see the supervised fine-tuning page. All right, and then they have exercise notebooks, which I'm definitely going to be going through. What is this? Okay, so let's just read the description for a bit. Chat templates. Learn how to use chat templates with Smol LM2 and process datasets into chat ML format. Uh, exercises. Do we have to do both the exercises or just one of them? Actually, can we do both the exercises or um, are we limited? Because, okay, it says convert the Smalltalk dataset into chat ML format. Oh, good. Okay, so that's what Smalltalk is. I saw the name Smalltalk pop up. Um, I think it was here. Yeah. So this is a dataset. They have I like this. They have Smalltalk and then they have Smalltalk, which is, I don't know, maybe a smaller version of this dataset. Oh, you know what? I came across this term recently. So I've heard of LLMs, but I don't think I've ever heard of VLMs. I came across this term I think yesterday or the day before yesterday when I was on Threads, looking at on Threads or on Twitter. I think it might have been on Threads because on Threads I follow quite a few. Um, I follow quite a few, ML, AI, data science, deep learning, and so on related people, and I'm always on the lookout for that kind of information. I'm a lot more active on Threads than I am on Twitter. You know what? I should probably change my my Nightbot message that it puts in whenever there's anyone in the chat. Uh, I should change that message to be follow me on Threads instead of follow me on Twitter because I post a lot more on Threads. Twitter is more now. It's like if I'm working on something, if I'm releasing something, I'll probably post it there, or every now and then there'll be like a random thing. But yeah, okay, all right. Um, okay, where was I? You know what? I didn't read this because I saw Fine Web edu being mentioned. I saw a filtered version of Fine Web dataset for educational content paper available here. Oh, this is what they released. Okay. All right. Good. Okay, cool. So they have data sets that you can use. These are all the data sets. Interesting, dude. Okay, so we can probably fine tune the thing. I mean, I don't know to what extent I can use these for the specific task that I'm currently doing, or the specific task that I'm currently learning how to make the model do. I don't even know how to say that sentence. I don't know if I can use. I don't know to what extent I can use these data sets for what we are currently learning. Let me just put it that way. But I guess we can find out. I guess once we learn how to do instruction fine tuning, we'll eventually get to that point. Okay. In the next exercise, so okay, here there's two exercises. One to convert Smalltalk dataset into chat ML format, and the other to convert one of the datasets from OpenAI to chat ML format. And then we have supervised fine tuning. Learn how to fine tune small LM2 using the SFT trainer. Use so and so dataset. Try out big code the stack small dataset. Okay. And then select a dataset for a real world use case. All right. Okay, cool. Great. So, chat templates. Chat templates are essential for structuring interactions between language models and users. They provide a consistent format for conversations, ensuring that models understand the context and role of each message while maintaining appropriate response patterns. Give me a second. Okay, actually, I need a couple of minutes. I'm going to switch to BRB and I'm going to take a couple of minutes and then BRB. All right, we're good. Um, I'm back. Also, welcome back. So, where were we? I guess let's just start from the beginning. So, chat templates are essential for structuring interactions between language models and users. They provide a consistent format for conversations, understand ensuring that models understand the context and role of each message while maintaining appropriate response patterns. Base models versus instruct models. A base model is trained on raw text data to predict the next token, while an instruct model is fine tuned specifically to follow instructions and engage in conversations. For example, small lm2 so and so is a base model, while small lm2 so and so instruct is its instruction fine tuned variant. To make a base model behave like an instruct model, we need to format our prompts in a consistent way that the model can understand. This is where chat templates come in. Chat ML is one such template format that structures conversations with clear role indicators, system, user, assistant, etc. It's important to note that a base model could be fine-tuned on different chat templates. So when we're using an instruct model, we need to make sure we're using the correct chat template. Okay. All right. Something so just a random thought. Something I need to look into later on, because I've mentioned this before, that I like the fact that things are, I mean, I don't know if they're completely, but a fair bit to a certain extent, but like a fair bit, they are they're kind of modular. They're kind of plug and play. So like you have the model, you have the data set. um you can have a base model, and then that base model can be trained on very general data, but then that base model can also be fine tuned to perform specific tasks. And that same base model, you can fine tune it on different types of data sets to perform different types of tasks, right? So this way you can have different people making models, different people making data sets, and you can kind of like try to use them together. I need to see to what extent that actually works, how well that works. And in order to test that out, I would need to understand the architecture of the various models that I'm looking at to see how compatible they are with different types of data sets. Because in terms of in terms of fine tuning and training, it kind of seems like your only your only limitation is the format of the data set, because the format of the data set has to be something that the model you're trying to train accepts. So either the base model was trained. What am I trying to say here? Either where was I going with either? I don't remember. Okay, so yeah, um, fuck, I'm losing my entire train of thought. What was I saying? Something about the thing being plug and play, and yeah, so different people can make the model, different people can make the data set, right? I need to see to what extent we are able to apply completely different data sets to completely different models. Because it seems, okay, now I'm getting my train of thought back. It seems like the only limitation right now, in terms of like what could be incompatible, right? Not what could break things, or well, not what could generate garbage. I'm talking about specifically in terms of what could be incompatible. It kind of seems like the format of the data set is what could cause an incompatibility, but as long as you have the right format, you should be fine. That being said, you could create a garbage data set and then train the, I should try doing that. Create a garbage data set and then train the model on that and then see the responses that I get. Cause I mean, it's probably going to be garbage, but like, I want to try that. It's one of the experiments I want to try doing. Okay. Uh, just a second. Where was I? Okay, so it's important to note that a base model can be fine-tuned on different chat templates. So when using an instruct model, we need to make sure we're using the correct chat template. Okay, understanding chat templates. Give me a second. Just need to do something and check something. Okay, all right. Um, just a second. Need to check something again. All right. Okay. So, understanding chat templates. Oh shit. Okay, there's the ad timer. So there's going to be an ad playing in a couple of. I completely forgot about the ad timer. It was right on the screen and I was just okay. Yeah, in like a couple of seconds there's going to be an ad playing. I guess at that point I'll take my hydration break and then we can continue. Do we just wait or now, you know what? I'll start reading and then I'll just interrupt myself if the thing starts. Uh, at their core, chat templates define how conversations should be formatted when communicating with a language model. They include system level instructions, user messages, and assistant responses in a structured format that the model can understand. This structure helps maintain consistency across interaction. Okay, there's the ad. So there's an ad playing right now, so I'm gonna take a hydration break. I'll see you guys in 30 seconds. All right, welcome back. So, they include system level instructions, user messages, and assistant responses in a structured format that the model can understand. This structure helps maintain consistency across interactions and ensures the model responds appropriately to different types of inputs. Below is an example of a chat template. Oh wow. Okay, there is like a okay, that's interesting. I'm start, I'm end. I'm start, I'm end. Okay, so the messages get wrapped within I'm start, I'm end tags. They've created their own like format for tags. Um, and then user and then next line. I'm guessing it's the next line that separates the user or the role from the content from the message. Um, right. Okay. The Transformers library will take care of chat templates for you in relation to the model's tokenizer. Read about how Transformers builds chat templates here. Sure, let's read about it. All we have to do is structure our messages in the correct way, and the tokenizer will take care of the rest. Here's a basic. Oh, good. Okay. All right. Okay. So this is why we are able to do it in this way, and we don't have to do it in this way, because Transformers takes care of formatting it in this way for us. Wait, does it always have to do that? Is that what's always going on in the background? How do I use chat templates? As you can see in the example above, what is the example above? Uh, oh, you know what? Let's start by reading from here. An increasingly common use for LLMs is chat. In a chat context, rather than continuing a single string of text, as is the case with a standard language model, the model instead continues a conversation that consists of one or more messages, each of which includes a role like user or assistant, as well as message text. Much like tokenization, different models expect very different input formats for chat. Okay, this is the reason we added chat templates as a feature. Chat templates are part of the tokenizer. They specify how to convert how to convert conversations. I thought that was saying how to convert conversions, and then I was like, what? But no, it's conversations. They specify how to convert conversations represented as a list of messages into a single tokenizable string in the format of in the format that the model expects. Let's make this concrete with a quick example using Mistral AI's so and so, so and so. All right, cool. So we have the tokenizer, we have this, apply chat template. Okay. Okay, so it's applying the template that this specific model is expecting. So when we look at an LLM or any kind of language model, does this mean that every language model that we look at, um, first of all, it's going to have its own like tokenizer, right? Or it might be using another well-known tokenizer. But if it has its own tokenizer, does this mean that somewhere in the model or somewhere in the description of the model, it's also going to mention what the chat template is? Because then I guess that's something else I should be on the lookout for with when I'm looking at LLM pages, I guess. Model cards. Notice how the tokenizer has added the control tokens so and so, so and so to indicate the start and end of user messages, but not assistant messages. And the entire chat is condensed into a single string. If we use tokenize equals true, which is the default setting, that string will also be tokenized for us. Now try the same code, but swap in the so-and-so beta model, and you should get. Okay, so what I'm getting from this, because the tokenizer is it says from pre-trained model, right? So it's probably using the tokenizer that this model is expecting, And so that specific tokenizer will, okay, so I guess then it's not the model, it's the model's tokenizer that has a chat template that may or may not have a chat template. Um, right. Okay. So if you do that, then you get this. Right. So this is a different kind of, this is a different format, but this format is probably what the tokenizer for this model is expecting. We should be trying this right now. Yeah, yeah, dude, we should be trying this right now. Though I don't know if I'll be able to run this. Dude, okay. Um in one of the previous streams, actually I don't remember if I even did this on stream. Yeah, I don't remember if I did it on stream or off stream, but there was a thing I was trying to look into. Oh, yeah. Yep. Okay, I remember. So, this was one of the shorter streams that I'd done. I wasn't able to do a long stream that day, unfortunately. And it was also one of those things where I started the stream and very shortly, like minutes later, I had to end the stream. And then I started the stream again because I was able to start the stream again. And then I went for maybe half an hour or 45 minutes or something and then ended again. Uh, why was I saying? Oh yeah, so there was a model by I think a research team at NVIDIA, or this was an independent research team. I don't remember. Might have been independent. Or maybe it was, yeah, I don't remember. Or maybe it was independent, but like the people that made it, they work at NVIDIA. I don't remember if there was some connection with NVIDIA. I don't want to like unnecessarily give NVIDIA credit and take credit away from, the individual researchers that did this work. So like, I'm trying to be careful there. But yeah, there was a model that I think it's called Llama Mesh. Yeah, I think it's called Llama Mesh. So this model, you could give it instructions to generate a 3D mesh. You could describe what kind of mesh you wanted to generate, and it would output all the necessary information of that 3D mesh. So vertices, edges, faces, maybe UV coordinates. I'm not sure. I think UV coordinates would be part of it as well, because UV coordinates are, how the textures will be applied, and how um, other information, like maybe, I don't know, normal mapping and all, will be done. Where was I going with this? Yeah. So the model generates all of that information for you. It just gives you that information. That's what the model is meant to do. It just gives you that information. It doesn't generate the model for you. It generates that information, and then you can use another tool. You can feed this information into another tool, which is what somebody did. Somebody actually made a Blender plugin that takes this information that the model gives and generates a mesh from it. Okay, so why am I telling this? So in one of the previous streams, I was trying to run the model, right? But there were issues here and there. I think after I ended the stream, I figured it out, or maybe it was during the stream. I don't remember. Either way, the point is the model was way too big to be able to run on the Kaggle notebook. The Kaggle notebook has what, I think 30 GB of memory, and even that filled up. Like, think about it. Like, even that filled up. And I'm guessing it also requires uh, inference on the GPU, just for better performance. But yeah, okay. I don't. Where was I going with this? I guess I was just trying to say that, yeah, I wasn't able to run it in the Kaggle notebook because the model was running, not even training, running inference on the model was quite heavy. Um, so I wasn't able to run it through the Kaggle notebook because it required a lot of resources. I don't remember why I was talking about that, but okay. I think looking at 7b here reminded me of that because 7b is 7 billion, right? And then m is million. So I usually try to go for the m, the million ones versus the billion ones. Um, wait, give me a second. Okay. Um, yeah, maybe we could try this out. We could test this out. Hmm. Actually, you know what? Hold up. So here's what I'm thinking. Here's what I'm gonna do. Dude, I'm getting really hungry. Cause I woke up and shortly after that I watered my plants and after that I started streaming. I didn't get a chance to eat. So I'm having a hard time like concentrating right now. I also don't know if if the sounds from my stomach are coming through on stream, but yeah, that's the thing as well. So here's what I'm gonna do, dude. I wanna do this on stream. I want to do as much of this course as I can on stream. But like now that I've started this, I don't want to just pause it until the next time I'm able to stream. So like I'm gonna mess around with this more. Uh, okay. I guess. Oh, you know what I could do? Because I still have some work to do on uh, on the VTuber app. I've been doing work on the VTuber app, just haven't been doing it on stream. And I've been making some progress with that. So I guess I'll continue doing that work, and then maybe in the next 12 hours I might stream again. I'm not sure. If not, then probably again in the next like 24 hours I'm going to stream again because I'm gonna get another chance to stream. Yeah, you know what? We could do that. We could pause the thing here and just continue tomorrow. I'm okay. So now that we've read about this chat template, you know what I could do? Okay, I'll read up on chat templates here and play around with chat templates by myself, so that tomorrow we can carry on with this. We can carry on. Actually, this is doing pretty much the same thing. Yeah, yeah. This is doing the same thing. This is teaching us about chat templates, and then this is going into much more detail with chat templates. So I think I'll read this stuff. Maybe not the entire thing because holy fuck, that is a lot of information. I don't think I need to read the entire thing. But yeah, I'll read a fair bit of it. And yeah. Okay. So here's what we are gonna do. Okay. Give me a second. Okay. Uh, you know what? I'm probably not gonna raid anyone today because I'm starving. I'm just gonna go and prepare something to eat. Maybe I'll raid someone tomorrow. Yeah. Okay. Cool. So, uh, yeah. So this was fun, and I'm glad that I got started with this course, and hopefully we get to learn a bit about fine tuning LLMs, and maybe we learn a little bit more because I'm already learning quite a bit from this. Like all of these different terms that we come across, and then we can do research on them. Like we get to learn quite a bit from that. So I'm happy with the progress that I'm able to make just by starting this. And then as I finish the first module, I'm pretty sure I'm going to learn quite a bit there as well. Okay, enough stalling. So, uh, yeah, that's going to be it for today's stream. Should I raid someone? I think I should raid someone. Uh, no, dude, I usually like to stick around after a raid, but like, okay, hold up. So the good thing about study streams is that a lot of people are already busy with, whatever other work they're doing. So they may or may not be able to give time to the chat. I mean, so a lot of times many of them follow a very structured format. Um, Unlike me, my thing is all over the place, which I like. I'm okay with that. But a lot of them follow like a structured format that, okay, we're going to study for so and so amount of time, and then I'm going to take a short break, and in that short break, I can talk to the chat, and then I'll get back to the studies, and or get back to the work. And during that time, every now and then, I might look over at the chat, but I'm not necessarily gonna. Now, you know what? Each of the people whose streams that I open up, they seem to be like either follower only, or verified this, verified that, or they're not in English. So I don't know if. um okay, whatever. So I'll raid someone tomorrow, I guess. That's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time.